Welcome back children, I am Srinivasan here. We are going to discuss exercise 1.1, ninth problem in the chapter relations and function. This is very easy question children. Show that each of the relation R in the set A, X belongs to Z. Z is a set of integers. What are integers? Yes, remember the number line. That will help you to understand what is integers, minus infinity to infinity, right? So the number set 0, plus or minus 1, plus or minus 2, up to infinity. Okay. So x is one of these numbers, as well as there is a limit for that. X lies between 0 and 12. So the set has become very small. So it starts from 0 because equal to is given there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 children. These are the elements in X. So I have written the set given by the relation R. What is the relation R? This is like a formula, right? That is our relation. So set of all order pairs A comma B such that difference of A minus B, the modulus of difference of, so when you find the difference, the negative will change to positive. That is the use of this modulus sign. Is a multiple of 4. Is a multiple of 4. Can you say, remember the table of 4? Don't think sir is asking very simple question, because the table starts from 0 actually. If we would have learned 4 times 0 is equal to 0, then you have to start 4 times 1 equals 4, right? Some tables we will not be using that, but it starts from there. It's also a multiple. It's a multiple of every table. 0 times that number equal to 0. Okay children? Okay. It's a multiple of 4. Now to check reflexive, take any one number. Any number you can take. 2. What is the difference between 2 minus 2? The same number, reflexive. It's reflections of the same number. So 2 minus 2 is 0. 0 is a multiple of 4. Take any number, subtract the same number, 8 minus 8. Again it is 0. So it is reflexive. It's clearly reflexive. So you need not want to take any one particular number and say it is reflexive. You can write with A itself. You can write. So for every A belongs to A, the element A says any number. That's why we are writing it as a common. Try to understand children. A belongs to A. We see that determinant of, modulus of A minus A is equal to 0, which is a multiple of 0 is a multiple of 4. Which means, what does it mean? The order pair A comma A belongs to R. Therefore, R is reflexive. Children, this got over here. It's a multiple of 4. First part over. Next, we have to show that it is a equivalence relation. So you have to show that it is reflexive, it is symmetric, and this is transitive. All the three. You are asked to show that. So this question is very easy. Anyways, you have to show all the three properties. Now we go for the second one. Now, what does a symmetric property say? For any order pair A comma B belongs to R, B comma A should also belongs to R. Now, choose any two numbers such that the difference should give a multiple of 4. I will take 1 and 5. Okay. Difference between 1 and 5 is minus 4. Obviously, modulus sign will change to 1 minus 4. Negative 4 change to positive 4, which is 4. It's a multiple of 4. What is 5 minus 1? Again, this is also 4. Right. So, when you say 1 comma 5 is there in the relation, 5 comma 1 is also there in the relation, because also 5 minus 1 is also divisible. It's a multiple of 4. Okay, children. That's also likewise. You can take 4 and 8. The difference is 4. 2 and 6 difference is 4. So there are so many pairs are there. So we will write it in common. For any two elements A comma B belongs to A. That means we are taking any two numbers from A such that A comma B belongs to R. You have to take in such a way that is difference between A minus B is a multiple of 4. That is the meaning of that what you wrote. 4. Then what you conclude? Which implies B minus A is also a multiple of 4. If you like to show an example, I will tell you after finishing this. It's a multiple of 4. Therefore, B minus A also belongs to R. Okay, children. If you like to show any example, you can write. For example, you can take any two elements from this. As I said, 1 comma 4. You take 1 comma 5 belongs to A such that such that you can write like this. This is a symbol for such that, or you can write SUCHTHAT. I am going to take 1 and 5 such that 1 comma 5 belongs to R. Okay, which means that is 1 minus 5 is a multiple of 4. Whatever I wrote with A and B, I am writing with a number now. Is a multiple of 4 implies difference 5 minus 4 is also a multiple of 4. Therefore 5 comma 1 also belongs to R. Therefore R is symmetric. Here also a conclusion. Therefore R is symmetric. Children, here I showed general is enough. But if you feel that I want to write with some numbers in the set, then you go for that. But don't forget to write this one. This they are expecting, because you cannot explain every number right now. So you have to write it in the general form. Here also, if you want to write an example, what you will write? Take any number 1. 1 minus 1 is a 0. It's a multiple of 4. So 1 comma 1 order pair belongs to R. Like that you can conclude. Now I am moving for the third part. For any A comma B comma C belongs to R. Okay, children, and you should say difference of A minus B. Difference of A minus B is a multiple of 4. Is a multiple of 4. Is a multiple of 4. Then difference of B minus C is also a multiple of 4. So what you are coming to say? That means A minus B belongs to R and B minus C belongs to R. So what we should imply? This implies, what's the conclusion? A and C. You are going to talk about A and C. You are right. You have to go. You are right. A minus C is also a multiple of 4. It's a multiple of 4. Okay, children. Is a multiple of 4, which means the order pair A comma C, I am erasing this. The order pair A comma C also belongs to R, hence it is transitive. That's all. So this implies A minus C is also a multiple of 4, which means A comma C also belongs to R. Therefore R is transitive. Finish, children. Okay, if you want, you can take 2 pairs and then you can share the difference. For example, I will take this itself. 1 comma 5 belongs to R. We have shown it. Then you take 5 and 9, and 5 comma 9 also belongs to R, because the difference is 4. So what about 1 comma 9, which implies 1 comma 9? What is the difference between 1 comma 9? It's 8. It's a multiple of 4. Also belongs to R, since the difference between 1 minus 9 is a multiple of 4. Therefore R is transitive. So we have showed reflexive, we have shown symmetric, we have showed transitive. Therefore R is an equivalence relation. That's it, children. Now the next part is very easy, right? A comma B, A equal to B is an equivalent relation. A equal to B, this is a separate question you have to do as I showed here. Now let us move to this part. Find set of all elements related to 1 in each case. All elements related to 1. So in this question you have number of 30 numbers, right? 0 to 12. You have 0, 1, 2, 3 up to 12 you have. In that, what are the numbers related to 1 which is a multiple of 4? 1 kuda ido number we are going to add. It should give a multiple of 4. We know the difference 1 minus 5. Obviously 1 minus 5 is 4, is a multiple of, okay, is a multiple of 4. Okay, what else? It's a multiple of 4. So 5 is related with 1. So likewise, can you say another number? 1 minus 9, can you help me out? Yes, it's 8, right? So multiple of 4. What else you have? 1 minus 12, it's 11, it's not. 1 minus 10, again it's 9, no other number. So you have 1 with 9, 1 with 5 and 1 with 9. So the elements which are related to 1 in each cases, this case is 1, 5 and 9. That's all. That is a final answer. Now you have to write 1, 5, 9 are the elements related to 1. That's all, children. This carries off mark will be allotted for this. So 1, 5, 9 are the line. Again, I tell you, if you have a small confusion, this 5 minus 1 is 4, 9 minus 1 is 8. So they are all multiples of 4. So what are numbers which are related with 1? That's it, children. This completes the question. You have one more part. I hope you will do it with this idea. Thank you so much.